The average weight of the cross girders over the weighbridge was 108 tons, actually. That was the only member erected by the aid of 2 cranes. They happened to be there, they used them. All the other cross girders were picked up by the centre point by 1 crane. The first cross girder was put up in its entire length. All the subsequent cross girders were put up at the little bracket to hold the footpath and the outside railway line were put on separately after the carcass of the girder had been erected.
The cross girders were connected by pins to the hangers. The large pinhole can be seen here in the bottom of the hanger.
That's an ancient mechanism, a battering ram. It's very effective for that purpose.
Each cross girder arrived with the pins resting in cradles at the side. The work platforms were added later.
One gets used to height, you grow with it. I was pretty scared on the first spans when I first started. But one gets used to the height. But when that cross girder was put across there, we'd only had a flimsy rope on one side, and one landed with a cage on that. It's only about 22 inches wide, studded with rivet heads, and with the shimmer of the light off the water, off the mackerel surface. It was most confusing. I felt most insecure for a while. You get used to it. The first time I really felt the height.
While work continued above the harbour, the pylons were also approaching their final shape. The pylons are hollow concrete chambers faced in granite. Dr. Bradfield said of them, "The granite-faced abutment towers and pylons, simple and elegant, are the architectural features of the bridge and harmonise with the lines of the arch. They give the touch of distinction to the bridge, which would otherwise be an immense utilitarian steel structure." The pylons added £500,000 to the cost of the bridge. The granite for the pylons was quarried at Moruya on the New South Wales south coast, where a temporary township was set up. Work commenced at the site in 1924. To shape the rock, lines of closely spaced holes were drilled. The granite was then split and scabbling machines worked off the rough. Final shaping took place in the workshop. As there were not enough granite masons in Australia, Dorman Long brought them from Italy and from Aberdeen in Scotland. At its peak, the Moruya quarry employed 250 workers. Finally, each stone was numbered for fitting into place at the bridge site. Wastage from the quarry was crushed and used in concrete for the pylons. The crushed granite acted as the ship's ballast and also as a bed for the shaped blocks. 3 400-ton ships with specially designed hulls were built to transport the granite from Moruya to Sydney. Docks for unloading were built next to each pylon. Altogether, some 18,000 cubic metres of granite facing was needed for the bridge project. These timber frames, known as centring, were used to form the arches over the footways and railway tracks.
And here you see them putting down the deck propping. It consisted of pressed steel 3/8 plate, about 18 inches centres and about 5 feet over the girders. Here they are riveting the droppings.
The heater boy dropped the white-hot rivet into the tube and stepped on the foot pedal. Compressed air then sent the rivet to the workman underneath the troughing, who pushed it through the hole for the riveter. The steel troughing was laid to provide support for the concrete, which would be poured later. Concrete mixing stations were set up at the ends of each approach viaduct, and this light railway took the wet concrete to its destination. In order to keep the dead weight of the bridge to a minimum, a special lightweight concrete was used after exhaustive tests of trial mixers. It contained metallurgical coke to give low density and lightness, and yet give a guaranteed minimum strength of 3,000 pounds per square inch. Mechanical spreaders were not used, just manual brawn. Tamping and screeding the concrete were also manual processes.
That's a picture showing us one of the expansion joints. There are only 3 expansion joints in the length of the deck, one at each end and one at the northern quarter point. The new Citadel asphalt proved to be unsatisfactory. It's a substance that has to be used immediately it's put down. It was left for some time before traffic used it, and it cracked up immediately, so it had to be all taken up eventually.
Manual rolling of the asphalt was out of keeping with the availability of diesel-powered rollers specially for this work. They even used hot irons to smooth the asphalt.
Of course, as the creeper cranes receded down the arch, the dock chord, they erected the seawork for the deck. That's the shortest hanger on the job, I think. That's a very short hanger just down near the deck.
All the hangers are in tension, including the 4 shortest ones. Inside the arch truss, the cross girders are connected to the vertical truss members. Just as the long hangers required a special erecting technique, so too with the shortest hangers. Each had to be manoeuvred into place using a short cross arm. Slings on each side gradually moved the hanger into the vertical position. Then it was raised to join the gusset plates under the arch rib and was finally fixed by rivets. Here the lifting yoke is attached to the middle of the cross girder, which is about to be lifted from the barge.
There was quite a good clearance in those holes, about a 16th round, the 14-inch diameter pin, to admit of easy driving of the pin. And there's a cast steel washer with secured by a nut on the end of each pin.
The last 2 sections of deck are put in place. These stringers, as they were called, span longitudinally between the cross girders. Once these were in position, it was possible to cross the harbour by the deck. In the background is the central troughing for the road, then a railway girder, a spacer girder between the hangers, another railway girder, and finally the footpath.
That's Mr. Davison, the then Minister for Works, Mr. Ennis, Mr. Bradfield. That's Mr. Muir, the civil engineer, Mr. Ceroli, Mr. Martin, Mr. Alf Martin, Mr. Henry Martin, the shop superintendent, Mr. Ennis, Mrs. Ennis, Mr. Charles Hipwell, Mr. Crow, the business manager, Mr. Hipwell presenting a bouquet to Mrs. Ennis.
One hole was deliberately left at the crown of the arch for the ceremony of installing the last rivet in the bridge.
Progress payments were made 5/16 on delivery, 5/16 on fabrication, about 11/16 on erecting in position and so on. But I remember the figure for the delivery was a penny .7825 pence per pound. So you can imagine making out the progress payments we made out in my office at the bridge. Monthly progress payments, we had to do some extending to arrive at the amounts for all these things. But we had a table. It wasn't very difficult. Yes, it takes about 7,000 gallons of paint to cover the surface. And we did run out the total area, which approximates to 123 acres. And if you work that out, for 70,000 gallons, it gives about the right coverage of about 760 square feet to the gallon.
This lightweight gantry was mounted on the underside of the deck. It's able to travel the full length of the deck and is still used for maintenance and painting.
I suppose I should mention that I had the pleasure of looking after this structure for 20 years with the Department of Main Roads, and along with the construction and maintenance of all the other bridges around about the place. There's the H.B. Helen B. Sterling going under the bridge shortly after the deck was completed. With very little clearance. I think Mr. Holt and I were down on the painting gantry underneath, and it looked as if she was going to scrape the cord, but I think it had a couple of feet to spare. It's a beautiful vessel. And of course, as a train run over the bridge, all these slippers and expansion joints, they move quite considerably, about 3/8 of an inch they slide. And when every train goes over the bridge, it flattens out the deck, has a flattening effect on the deck. Just the first train over the bridge. It happened to be a ballast train. They hadn't had the City Railway business link finished to come through Central Station, so they came via Hornsby over the bridge to put ballast in the tunnel between the bridge and Wynyard Station.
Ennis and Bradfield, as always, were on hand for an important occasion, and Bradfield joined fellow engineers on the train for the return journey. The Harbour Bridge was a key link in Bradfield's plans for the city railway system and electrification of the suburban lines.
There was about a test load of roughly 8,000 tonnes of locomotives and tenders full of water for various tests. At one stage they were put all on the quarter point, which is a very severe test, and caused considerable distortion, of course, of the arch. Measurements were taken of all these distortions, which have worked out pretty closely to those that calculated. Dr. Bradfield, Mr. Ennis, that's Mr. Davison, the Minister for Works. That's Mr. G.W. Mitchell, the Director of Public Works, on the right. I don't know whether that is the first tram, but it is certainly one of the early ones that went across the bridge.
The tracks on the eastern side of the bridge were used for trams for almost 30 years, travelling through tunnels to Wynyard Station. By the early 1960s, they had been covered and are now used for road lanes 7 and 8. The canopy of cantilever beams on top of each pylon supported flying scaffolding on all four sides. Workmen on the scaffolds scrubbed the granite faces clean. The cleaning process started at the top and worked down. Finally, the great day came. Unnoticed by anyone, an extra horseman, Captain Francis de Groot, had joined the rear of the light horse escort, with historic consequences. The captains of Fort Street Boys and Girls High Schools delivered a message of goodwill from the country school children of New South Wales. Incensed that the bridge was not to be opened by royalty or by the Queen's representative, Captain de Groot galloped forward and slashed the ribbon with his sword. He was quickly hustled away, and the ceremony continued. A pair of ornate gold scissors were specially made and presented to Premier Lang for the ribbon-cutting ceremony. The opening ceremony was followed by another on the northern side, and then a procession moved proudly across the bridge.
One noticed that the men themselves were very keen, there was great keenness amongst the workmen who felt themselves associated with the construction of this bridge, and I think that it was a very good thing. And they shared the enthusiasm of even the engineers.
There were celebrations all round, but particularly on the harbour. HMAS Australia and Canberra were present, hundreds of small craft packed with well-wishers were on the water, and ocean liners such as P&O's Orford were part of the harbour procession. In the air, Sir Charles Kingsford Smith's aircraft, the Southern Cross, joined in the celebrations. Finally, thousands of people walked across the bridge. These scenes were to be repeated on the 50th and 60th anniversaries of the bridge. Today, around 176,000 motor vehicles and 400 trains cross the Harbour Bridge every weekday. It is maintained by a team of approximately 100 men and completely repainted every 12 to 15 years. No major components of the bridge have been replaced since it was built, and it remains in very good condition. It is expected to provide service until well into the next millennium.